Hi, my name is Ralph Hollis. I'm from Carnegie Mellon University. And the title of my talk today is Maglev Haptics, and that's also the take-home message. So if you don't remember anything else I say, remember those two words. If you can't remember it, write it down and put it in Google, and you'll find lots of pages describing it. Maglev means magnetic levitation. Haptics is interacting with computed three-dimensional environments using the sense of touch. So I think you're probably familiar with a plethora of haptic interface devices which are now on the market. The interest in haptics is absolutely exploding. This year is a new IEEE transactions on haptics, for example, and there are a number of companies producing devices. These devices are fine, but they're all mechanical devices. They have friction, backlash, inertia, link bending, flexibility, and so forth that we chose not to like. The reason we don't like it is that it interferes with the exquisite sensitivity of the human hand. So we've taken a completely different approach. I want to run through this. Imagine a magic floating mouse that's just floating above your desktop at a comfortable position, at a comfortable angle. You can put your hand, maybe rest your forearm on the table or on something. And it's connected logically to some kind of MCAD part model, for example, so that you can control the position and orientation of the part model like that. You can move it left, you can move it right, you can move it forward, move it backward. Okay, so far it's a mouse, but now you can also move it up, you can move it down, you can yaw it left, right, down, up, roll left, and roll right. So you have 6 degrees of freedom, sort of like a space ball, you know, ho-hum, right? Logitech, I think, has sold 25,000 of these things, and they work great. But the difference is, when you move it, you get force and torque back on the handle of the magic mouse that's floating above your desktop. Okay, so we don't actually use magic. We use magnetic levitation, and this is how we do it. There's the magic mouse. It has a little stem coming down. That's connected to an upside-down umbrella that has spherical coils embedded in it. There's some hardware that goes around it like that. We have permanent magnet assemblies on the inside. We have a magnet shield. We have some outer structure. We have more magnets on the outer surface. And we have optical sensors that track light-emitting diodes that are attached to the floating part, the umbrella, which we name the floater, F-L-O-T-O-R. We add a few more pieces of sheet metal, some electronics, and voila, we have our new magnetic levitation haptic interface device. Now, it's more than just a theory. We have shown here that the friction, indeed, backdrive friction is essentially zero, and we have very high performance shown by these graphs. For example, minimum position resolution versus maximum achievable stiffness. High stiffness means you can simulate a rigid contact with high fidelity. So we believe it has a lot of facility for computer augmented design. You can imagine a designer putting a three-dimensional part into a complex assembly while feeling the tolerances and fit and function and so forth. Also augmented, flexible objects can be simulated, like plastic snap fit can be evaluated in the design stage. We think there's a big use for data visualization interaction. This is a CFD computation of flow. For example, scalar data, MRI or CT data. This is an earthquake simulation, tensor data. So you can reach into these data and feel the tensor, or move up to the surface of the earth and feel the earthquake actually in real time with this technology. Also surgical training, microsurgery, dental training and design, and robot vehicle control, both ground vehicle and aerial vehicle. And finally, maybe not finally, but micro and nano manipulation with a scanning tunneling microscope or atomic force microscope. We built 10 of these. These universities are getting the systems. And we've just spun off a company to commercialize it. We'll have product in June or July. Thank you.